Hello. Hello. Let's get things going here. So, this time I wanted to take a look at implementing a staged asset loading system for trial. But the unfortunate news is that I already spent the entire day programming and debugging and testing and stuff, so I'm kind of burnt out right now. Which means...
Good evening.
Hello, good evening. Means, I'm kinda... tired, so... Not sure how much we'll get done, but I'll give it a try nonetheless. Now, you may be wondering what I even mean by a staged asset loading system. And that's fair enough. The answer is that it's a problem I've already talked about before. Which is to say, actually, let me, hold on, I'll pull up the thing here. Let me sketch some stuff, huh? Got a fucking Wacom and everything, so might as well put it to use. Basically the idea is that when you have, well, usually what you want to do is you want to encode all your game objects and like landscapes and whatever's and like figures that you have. Yay! You want to encode these in a sort of a container, and in Trial this is called a scene. A scene is a combination of a sort of an asset, of a sort. A scene is a combination of an event loop and a scene graph, basically. So the event loop is there for, well, delivering events. And the scene graph is basically it's a graph of connected components that you want to draw. So, for example, for this scene here, you would have a graph that is like, I don't know, you have like landscape. And then you have like, person. And you have like, ball. Then you might have like sub things in the landscape, like a fucking tree or like, I don't know, a house. So it forms a sort of a graph, and sort of when you draw the scene, you traverse this graph and you draw all of these things. Now, oftentimes what you need to do is you need to transition between different scenes. So for example, the easiest to explain example would be if you change your maps. So for example, the person enters the house, so you have a collision with the house, and now you need to load a new map, which is the interior of the house. So what you need to do is you need to sort of transition to a new scene where you have scene 2, where you have the person still, but now you don't have a landscape anymore, and you probably don't have the ball anymore, but you have like I don't know, a house, and then you have like a table or something, and you like, now he's unhappy because he's inside a house and he's very claustrophobic, so that's no bueno. And then there's like, I don't know, a chair. There you go. Fantastic drawings. I'm an artist, I'll have you know. So, yeah, what you want to do is you want to be able to transition between scenes. Now, while being able to transition between maps is like the obvious kind of thing to do, you can also use this kind of mechanism for much more than that. For example, if you're in the main menu, where you have a scene of just menu components like, I don't know, start buttons and micropayment things or something, I don't know. And then you want to load into the game, and you need to transition the scene into something that has something actually playable in it. Or, for example, if you have a save game, so for example, you saved at a certain point and the user wants to reload that save, then you would also have a scene transition between the current world state and the newly loaded save game. So this kind of transition happens fairly frequently, and it's rather important that this works well. Now, when you actually transition, a couple of things need to happen. Most importantly, well, you need to build the new scene graph. And that's something that you can't automate because, you know, that depends on what exactly you want to display on the scene. So that's on the user. So the user of trial is going to decide, okay, so my new scene is going to contain all of these things, and then the system needs to figure out how to load all these things so they can actually draw them. And the loading part is what we're interested in automating. Now, the reason why I call this the staged system is because in this you have sort of fixed stages, which is the first scene is the stage 1, that's a stage, and the second one is also a stage. There's no sort of continuous loading going on. You have separate stages and you want to transition between them. The automated part of the automated stage scene transition thingy is that it should figure out which assets it needs to load and unload automatically based on the scene graph, rather than you having to define explicitly for each object which things it needs to load and unload when you need to draw that object. So the way it currently works is that if you have an object like a person, then you need to say, okay, like I have different kinds of sub-assets. So for example, I have a texture thingy, I got a mesh. I might have like different kinds of sub-meshes for like the clothing or whatever. So I might have more than these and more textures, and I might have like other kinds of objects as well. For example, if the player is holding something, I don't know, you might have a sword, and that in itself might have a mesh and a texture and so forth. So you have different kinds of things that you need to keep track of and load. So if I were to mark things, then these would be assets and these would be entities. The difference is that assets in themselves represent a sort of a static resource that needs to be allocated in some way. So each asset has some kind of mechanism to load and unload. You cannot automate loading an asset, but you can automate loading an entity, because it doesn't, or it shouldn't, in itself have anything that it needs to explicitly load, aside from the assets and other entities it refers to. So the first part of our system here that we need to have is a way to traverse this scene graph. So we need to be able to automatically walk through a tree of, or a graph of objects. And this needs to work for a large variety of things, potentially. Because potentially the user could store things in lists, in vectors, in hash maps, in custom structs, in custom objects, and so forth. So we need to have a mechanism that is generic enough to allow traversing practically any structure, as long as it is somehow told how to traverse it. Now, when I think about this, I run into an issue, which is to say that I'm not sure if it is entirely wise to try and traverse everything. there's certain issues that arise when you try to traverse things, because for instance, looking at a field in itself might have side effects, which is bad coding style, but it could happen, and I can see reasons why you might want to do that. So that in itself is already kind of iffy. The other problem is that if you have cycles in this, detecting cycles is a difficult problem unless you allocate a lot of memory and make it really slow. So that's another problem that I'm not sure how to deal with. What you can do to combat these problems is, on one hand, you can say, okay, we're not going to have a graph, we're going to have a tree. Then we don't have cycles, and we don't have that problem anymore. The other one you can say is, okay, we're not going to traverse all kinds of structures. We're only going to traverse certain structures that we know are safe to traverse. Like, for instance, entities. And perhaps lists and vectors. So, those are considerations that you need to make when you design a system like this. And right now, I'm not entirely certain on what my decision should be. I haven't thought about this much at all before the stream, so we're gonna have to figure this out now. What else is there to do? Right. So, disregarding this traversal problem, what the system needs to do is, when it finds an asset, it needs to save that asset into a sort of a global, I don't know, it saves it into the list, I guess. So, texture goes in there, the mesh goes in there, this mesh goes in there, and this texture goes in there. Then, it needs to do the same for the previous scene. So, for example, we have, for this scene, we have built a asset list. And for this scene, we also need to do the same. So we also have a list of assets. Asset list. List of assets that we have already loaded. So these are loaded and ready to go. And these are need to be loaded. Oh, Infinicil is saying the traversable type class from Haskell will be the thing you need. Yes. So what we can do in Common Lisp is say, okay, we define a class that needs to be the superclass of all traversable items. That's okay, but the problem is that for certain kinds of structures, like for example if you define a struct, you won't be able to put this class as its super type. So that's a bit of an issue. But instead of doing it with types...
Can you just use def type?
Def type is not extensible, my man. If the point is that the user can add new types to this traversable kind of thing, then you can't use types. What we can do instead is use generic functions. With generic functions, we can let the user just write a method for whatever type they have. The fortunate part is that structs and classes and pretty much every type that we care about, and thus all their subtypes, are dispatchable using class. So we're gonna have probably gonna have some sort of generic function that is like traverse for loading or whatever, or traverse finding assets, or find assets or something. And is going to, you know, be able to walk through the tree. Anyway, going back to this. So now that we have both scenes, the scenes are built, and we have traversed them to find out our complete list of assets that we need to have. What the system then needs to do is it needs to compute the difference between both lists in both ways. So it figures out
which assets it can offload and which new assets it needs to load, and thus it has a minimum set of operations it needs to perform in order to transition to the new scene. And once that's done, it can well, execute the loading and offloading. And then the new scene is loaded in and ready to go, and it can be displayed in your scene, or well, in your game, or whatever the fuck. So that seems to be the plan of all of this. Now, it's all well and good, but it is... I don't think I do this right now, but it seems conceivable that an object might need to dynamically create certain kinds of assets rather than having them... No, does it? Is that really something that needs to happen? What I'm thinking about right now is that if you have an object that's already instantiated from a class or whatever, is there a situation that could arise in which it might need to produce an asset only once the scene it is in is actually loaded, rather than being able to create the asset ahead of time when it is instantiated from the class? I'm actually not sure if there's a case for that. You could argue that loading it would be sort of like a sort of a final step or something that finalizes the instance. So what I'm thinking about is sort of, if you have, like, say we have a box which has a width and a height, and then it has an asset that actually draws the box or whatever. Now, you might want to create an instance of the box and then dynamically alter the width and height. And the box asset should only be created once it is loaded, because only then we know the final width and height of the thing. That's a very primitive example, but in that case, the asset would not exist when we traverse it, and it would only be created once the entity is loaded. Assets should be static, so if it gets generated dynamically, it's not really an asset. Well, we're conflating concepts here. So, an asset in Trials terminology is an instance of a class that derives from asset, which doesn't say very much. But in essence, what the idea of the concept is in the engine is, it is something that represents some kind of resource that needs to be allocated. So for example, a texture is an asset because it needs to be allocated on the GPU, or a font is an asset because it needs to be loaded from a disk, or say, you could also say a really large text file or a sound file is an asset because it needs to be loaded at some point. So that's what an asset is. Assets can also be generated dynamically at runtime, so there's a lot of uses for that. I guess you could argue that a better name would be resource, but then, I don't know, you know, resource isn't really you could make cases against the name resource as well, and you know, at one point you just realize all names kind of blow, so just choose one. Okay, so back to the box problem. I'm not sure. So I guess the asset would need to be created when the traversal happens for the loading. At the latest, that is. So there would need to be some kind of extensible system, some kind of protocol for an entity to say, okay, here's some assets that I want to load. So maybe we have... maybe you have a function, say, compute assets is gonna take an object of any kind. And this is gonna be an append, probably. Yeah, an append would work. So would use an append method combination. Does that always work? So my current idea is that you would have this generic function compute assets, which is responsible for figuring out all the assets recursively that need to be, that this sort of object might touch in some way. So you would have sort of a generic method, or a method for just entities that simply traverses all the slots in the object and calls compute assets recursively. And then you might have sort of a method on box that simply computes this asset here and returns it in a list. So that way you could get that going. Because the method combination is append, it would automatically combine that with this one, and you would get the complete list of entities recursively. I guess that works. Not sure I like the name though, because no, that doesn't sit well with me. Because what I'm, well, from the perspective of the box, what we have is sort of a step that bakes the box to be drawn, because it creates an asset and then this asset is sort of fixed. So we will probably need a different kind of thing to happen, which is to say, in order to compute the assets, we need to call bake on an object to finalize it. When the box is baked, then it creates an entity and stuffs it into some kind of slot within itself, so they can reference it later. And then this will be picked up automatically by the standard traversal rules. So we wouldn't need to have this be an append anymore, because the bake will be... yeah, I don't think the having it really be extensible is necessary, because when you create an asset, even dynamically, you need to put it somewhere so that you can reference it and use it later when you actually, you know, draw stuff or play or whatever. So there's no need to create sort of an independent function that allows you to supply these assets, because they need to be referenceable, traceable somehow anyway. So that should work better. Okay. So compute assets would use you call bake, and then it would use some kind of traverse function on the object that can generically traverse any kind of structure. I'm not sure if that's a good idea, because then you would lose the ability to distinguish between the generic kind of traversal and the traversal for the purpose of finding all assets. So maybe compute assets just should be recursive in itself. Or maybe... Yeah, nah, I don't like this. Hiding too much. Okay. So the outline is for when you transition from A to B, then it would do all compute assets. Of A, and then it would compute assets of B. And then it would have set difference. I always forget in which order set difference works. Let me check. Set difference returns a list of elements of list 1 that do not appear in list 2. So these would be unload, and then yes, AS would be the assets to load, and then you would unload. And then you would load. And then you could... And then I think you can just throw away the reference of the first scene and let it be garbage collected. Since we took care of all the assets, we took care of all the foreign data that is statically allocated, and thus it should be fine to GC. So then we can GC. And we're done. So that should be the general procedure for a scene transition, I think. Am I missing anything? Repeat baking of an object should only happen. So when an object has been baked, it shouldn't rebake itself. So that needs to be an invariant. Makes me worry a bit though. For example, consider this. If you have a scene transition between 3 parts, so you have sort of... So you have a ball here, and then you have a menu here, and then you have a ball, the same ball again here. So now when you transition over to this, the ball gets unloaded. If the asset is generated dynamically, then it's unloaded here and reloaded here, because it, well, the object gets baked here, and then it remains baked even when it's loaded again. Now, if for some reason that object sticks around until you transition back. For example, let's say you keep the scene around and you transition to a pause menu. So you have pause, and you have a game, and you transition between these scenes for some reason using a costly pause and unpause. And you wouldn't remove the game scene, obviously, and thus this ball would stay the same. Well, in this case it doesn't matter because you probably wouldn't want to rebake it once you load the game in again. So I'm trying to figure out if there is a use case in which an object, when the scene which contains it is loaded again, the object might need to be rebaked. The reason why we have to have bake be once only is so that we can compute the assets of the currently loaded scene without causing a change to the entities that it contains. Because we might have the case that the new scene fails to load for some reason, or is aborted for some reason, and then you need to transition back or roll back your operations, which means these need to be actually switched around. So you can fall back to the previous scene without losing any kind of state or crashing your shit. Which means... Which means what? Is there a case where you would want to rebake? I suppose what you could say is that we would have to add a sort of a part that unbakes an object once its assets have been... once the scene has been decommissioned. But that might also incur too much recomputation. It's not always the case that you want the entity to be rebaked, but you might want it to. Or you might expect it to. What can we do about this? Also, let me check if anyone's trying to use Twitch chat for some reason, because that sometimes happens. Oh shit, ads. Yep. Alright, back to problems. Let's see. Yeah, I think it might be useful to have a general kind of hook that fires if an object is... Nah. Is there really? Is there really?
Hello, and I'm sorry I'm late.
You better be, motherfucker. Because you're now missing the entire context for what I'm doing.
I'm not sorry, I forgot.
I don't care about you, dude. You don't know what's going on anyway. I don't think it's necessary to have a mechanism to unbake an object, because if you do keep the scene around, if you do keep an object around and reinstate it with a scene, then the most likely thing is that you want to just recycle the scene and you wouldn't expect it to change, thus rebaking it will be counterintuitive. And if you do want to rebake it, then you will probably have some kind of custom mechanism to reinitialize the object anyway. So you could have a thing like reinitialize instance or whatever to ensure that the object is updated as you need it to be. But what we definitely need is some kind of check for whether it's baked. So we need a baked P. Which I don't think I can automate either. Because you might need to bake several objects, and thus checking whether it's successfully baked would need to have several kinds of checks. I guess I could have I could just make a sort of a slot on a bakeable object, and it's set automatically after bake. Yeah, that will work. So we have a bakeable. Any other cases that could happen? That's a bit too much. Edge cases. I don't suppose anyone else has any ideas? Alright. Since Gendrail and Entropy just showed up here, I guess I'll try to re-explain. So what we're doing is we're designing a system for scene transitions. A scene in Kyle's nomenclature is a sort of a graph of objects that are displayed or that are part of the game world or part of what you can interact with. Now, frequently what you want to do is transition between different scenes. For example, here we have a transition between a house. So for example, if the player walks into the house, then we transition the scene into the house's interior. Or for example, if we have a pause menu, we have a scene with all the menu items in there, and we want to transition into the game world, so we load that in. When a scene is transitioned, what needs to happen is that all of the assets that are needed by the objects in the scene, in the new scene, need to be loaded, and all the assets that are no longer needed from the old scene need to be unloaded. So what we want to do is we want to have an automated system that traverses the scene graph, figures out all the assets in the scene, computes the difference between the old scene and the new scene, and then unloads and loads as necessary. So the crux of this is this compute assets function, which recursively computes all of the assets that this object and its sub-objects might need. One of the issues that might arise is that an object might dynamically determine what kind of asset it wants. For instance, if you have a box with a customizable width and height, then it can't create an asset from the get-go because it doesn't necessarily know what its width and height are when it is created. So when you instantiate the box, you don't necessarily know the final width and height yet, so you can't create your asset. You need to do that just before the scene is loaded. For this reason, compute assets calls a bake function on each object that it touches, and this bake function should only be run once. When it is run, the asset is created and stuffed into a slot somewhere in the object, so that compute assets can find it and then put it onto its list of assets that it has found in the scene. One of the problems that I was considering is this here. If you have a scene, like for example the game, where you have a ball in there, you transition to a pause screen and then you transition back, then you have this, you get a bake in the first time the game scene is loaded, you bake this ball into its fixed asset, and then you transition to pause and you transition back, and the ball is still baked. The question was, is there a case where it would be useful for the entity to be rebaked automatically by the system? And I think there isn't. Mostly because since you already loaded the scene once and you're still keeping it around rather than, you know, creating it anew with all its entities also being new in it, you wouldn't expect it to change when you transition back to it. So rebaking it would be unintuitive. So we have this once only property for baking, which means that once an object has been baked, it cannot be unbaked unless the user provides a specific mechanism for it themselves. So that's the current sort of layout. And here you have the kind of the general procedure of the transition function. It computes all the assets from the first scene, computes all the assets from the second scene, computes the difference between the asset lists to determine which ones to unload and which ones to load, and then it unloads and loads. And that should be everything. My final question was, are there any edge cases that I'm not considering that might be unfortunate or might make this system awkward to use, or might make it especially inefficient or cumbersome, or pretty much anything? Since we're in the design phase, trying to come up with all possible use cases and edge cases and all sorts of things is fairly important. So hopefully that brought you back up to speed. If you have any questions, please do let me know. I'll try to answer as adequately as I can. The reason we want this system is because currently what you have is two generic functions, load and unload, and you need to manually specify all the assets and sub-entities that you need to load.
What does baking do exactly here?
Baking creates the instances of the assets that the object is going to need. So if you have a box that has a customizable width and height, when you create an instance of the box, you might want to let the user change the width and height a bit later still. So you don't want to create the asset with that fixed width and height quite yet. You want to do that at the latest possible point. And that point will be right before the scene is loaded. And that's what bake is for. So bake on this box will create an instance of an asset with the proper width and height and stuff it into a slot in the box. And then compute assets could discover this slot and this asset and use it in its list for things to load. Note that when I'm saying create an instance of an asset, assets can be created without being loaded. When they're just created, they're basically a representation of the parameters necessary to load that kind of thing. But an asset might not be as flexible in its changes, so you might want to defer the creation of the asset until later. For instance, if you have a mesh, the asset is going to have vertex information in there to upload to the GPU, and changing those is kind of cumbersome without just recreating it entirely, so it might not have any options to change itself. So you will want to create that asset at the latest possible point. Anyway, back to what I was saying before. Currently it's incredibly cumbersome because you need to basically manually traverse the entire scene graph.
Yup, got it.
In order to let the system load and unload everything. And it's a thing that only works in an all or nothing scheme. So you can only entirely unload or load an object and its sub-objects. You can't partially do it. So for instance, if you had something that shared assets, for example, if you have multiple player characters that each share the same kind of sword object, then you could only unload or load the entire thing, including all of its sub-entities, which would not do what you want. Or rather, it would, but then you would unload the sword and then immediately reload it, which is really stupid. So using this kind of flattening scheme and set difference, we can optimize that to the, I think, perfect minimal amount of unflash loading operations necessary to perform the transition. One of the edge cases we talked about was the potential of the scene graph having cycles, or, well, diamonds in it, or even cycles, I don't know. Some kind of structure where it's not a tree anymore. In that case, the traversal would need to be able to detect cycles and abort the recursion, so that it doesn't either, in this case it would, like if you have directed graphs like this is a DAG, so in this case you would duplicate the traversal, which is not great, but avoiding this is easy because you can just say, well, it's not very easy actually. Not easy to do unless you add a property to each. Or if, even worse, if you have a cycle, then the traversal is going to hit its pants. So there needs to be a mechanism to avoid that as well. I haven't really thought about that. The primitive schemes of keeping a list of already traversed objects is kind of shitty, because it uses a lot of memory and it means it's n squared in time complexity, just, well, complexity were just a traversal, since for each instance you need to check all the previously traversed instances, figure out whether you've had it. You can optimize that a bit with a hash table so that the lookup is at least amortized 01. But still requires saving all them, which might not be what you want. Which is a very corner case kind of optimization thought process, but I mean, I'm probably gonna be fine for now. It's really an optimization corner case, but I like to consider all the possible cases in the design phase so that I can avoid writing myself into a corner and having to refactor large parts.
What about streamed loading? If you want to be able to enter a new scene without the player noticing that it's a new scene,
then that's not really part of this system. This is a staged asset loading system, so there's distinct parts and potentially a loading screen in between. So this is really not made for streaming. For streaming, I don't think you can make anything automated. It needs to be custom tailored to what you're doing, because there's a lot of information flying around that you need to know about in order to be able to do the streaming. For instance, if you stream geometry, you need to be able to know how to update the vertex data, and that's already very application specific. Or if you load in new textures, you need to know how to update the regions optimally and so forth. So I don't think there's an easy way to do something automated for streaming. Ad Entropy saying, to me this seems like the cell system using Morrowind. I have no idea about that. I'm not familiar with Bethesda's engines.
Fair enough.
I mean, if you stream, then you're never going to change... Well... Typically, if you stream, you're not going to actually... Okay, I'm gonna try and avoid talking out of my ass here, but a large part of streaming does not involve any objects disappearing or reappearing. What you're doing is you're changing existing objects, which is already very far apart from this system. You do sometimes load in and unload parts, like for example buildings and maybe trees or whatever that disappear or appear. And in that case, you can still use parts of this system. You can use the compute assets function to automatically traverse the new objects you're entering and figure out which assets to load based on the currently loaded assets list and the difference to that. So you can use a part of this to determine what to load, but I wouldn't imagine it to be extremely efficient. So it seems to me like you would want, probably if you're getting into performance constraints like that, you're probably going to want a tailored system anyway to make sure you're really fast. So, yeah. Oops. Entropy, can you elaborate on the Morrowind system or cell system that you're talking about? Also, can you prefix your chat messages with my username? There's tab completion and everything, so it should be easy enough, because then it goes on TTS and I don't need to repeat it. Actually, hold on. I want to make TTS a bit louder. It seemed kind of quiet.
This is a test text to make the volume louder.
There we go. A bit louder. Still trying to think of edge cases. Why did I fucking... I'm such an idiot. Turn it into bakeable instead of bakeable.
I'm trying to think of a way to describe the cell system.
Okay. Is it Googleable? Interior cell names. Seems to be kind of way to describe maps. Actually, I don't think currently the system even allows having any kind of structures like this or this. Wait, no, yes it does. As long as they're not being passed to paint, you can do that. But because we need to transparently traverse things, we need to take care of that in this. Yeah, I think I'm just gonna keep a hash table of a hash set of the objects currently already traversed. That should be good enough for a first approximation of the system. I'm not sure if you can even do better. You could possibly do something where you like skip out every and only save like every 10th object or something to reduce memory footprint, and then you would incur potential retraversal, but only if up to 9 objects or whatever. So I don't know. That seems like something we can disregard for the time being. Something else I've been thinking about though is again being able to customize. You can do that already by defining your own method on this. So you could have some like that there's a custom traversal rule, so it doesn't consider certain kinds of slots if you want to avoid that. Yeah, that should work. Yeah. Looking good, I think. One thing to optimize would be this here, the computation of the assets of the currently active scene. I'm not sure if there's ever a reason to keep assets loaded that are not part of the current scene. Is there? I guess you might want to do that if you wanna. No. Since the transition system is already not going to unload or reload stuff that's the same between scenes, you could just keep the object active in the next scene to avoid it being offloaded. Because then you could eliminate this computation entirely and instead do something where you just use the current asset list, so the list of currently loaded assets, which is already a thing that exists, I think. Let me check that. I'm not entirely sure. Asset. Do we have that? I think we do. Maybe. Asset. If assets. I think we have something in main. Finalize. Acquire controller. Pipeline scene. I thought we had something for that. Air pipeline. More buffers. Maybe? Maybe I got rid of that. I don't know. Oh yeah, we do. It's saved in the context, right? That's only for OpenGL assets, though, I think. Yeah. Asset. Is it? Or is it for everything? No, it's for everything. Okay, so we do have a table of all the assets that are currently loaded. So you could traverse that to get a suitable output.
Sorry, I guess I was thinking of something else entirely. My bad.
Okay, well, it's fine. Okay. So, hold on. I think I'm gonna keep this optimization of removing the compute assets for the first thing for the current scene in mind. But we're gonna just do it like I have it here for now, so that we're sure it's correct and not doing anything overly awkward. Okay. Unless there's some other questions or remarks. All right. Let's implement the... What should I call this? Call it a loader. Loader. Ray, I got a bug ticket.
How are you going to test this system? Do you have some things you prepared already?
Testing it is easy. You just populate two scene objects and then transition and see if it does it. I don't have anything prepared, but setting it up should be trivial. For instance, we might have... What is this? Oh, that's... Okay. So, yeah, setup scene is going to be a transition as well. Anyway, but I don't know. I'm gonna go worry about that later. Okay. What was I saying? I was calling this generic feed assets of generic position from to object, and then we have peak. Okay, I think that's everything. So we have class bakeable baked p. Bake after bake. Actually, this should probably be even later, so we're gonna make it in rounds. See, and we're gonna check. Yep, that takes care of that. Then we have the method transition from scene to scene. Let as repeat message from to load unload that difference. And then we have load I can actually do this. And that's it. And then we need to have traversal assets before bakeable bake. Oh shit, I love class so much. That kind of stuff. This, oh, so good. Alright, compute assets for... Is cons a system object? I think so, isn't it? Oh, I know, you told me already about the white line thing, which is this here. I'm not sure if you can even see it on stream, but there's like a... You can sometimes see it. There's like this really gross, bright white line for some reason. It doesn't... Emacs for some reason stopped really respecting the themes in that regard. I don't know why, but... Anyway. Hey, cons is, I'm pretty sure, a system object, isn't it? Cons. Yes, it is. So, cons... map car... Compute... Cons. Though, actually... Do we want to have trees? Probably. There needs to be ncon compute assets. Car compute EDR, and then method compute assets. Null is going to be the empty list. And that's tree traversal done. Compute assets. Vector is also system class, isn't it? Vector. Yes, it is. Perfecto. And we're gonna do map list. Compute. No, actually, it shouldn't be map. Reduce. Nah. What's This is also kind of gross, but don't know of a better. Whatever. We can worry about it later. Viewed assets. Yay. Viewed assets. Struct. Standard structure. That's a class, isn't it? Standard structure. No, it isn't. What is it then? Is it a standard object? No. Where's structs in this? Structure class is the name, and structure object. Okay, not standard object. Okay. Structure object. I don't think it's defined in the map whether you can actually retrieve all the slots for the struct for structure class. Let's see, this struct fart AB and then find class. Okay, that works though, but I'm not sure if it's very portable. Not that I care too much for trial. Okay, so we wanna do. Is there a common superclass for a structure object? Instance of structure class, superclass of every class. Of a struct. Nope, it's only T, so there's no find one. Does the mop define something? Where is the fucking mop? Awesome. Where's the fucking list of standard things? Is there even one inheritance graph? Yeah, it doesn't care about that. Okay, the map doesn't say. That's a shame. Okay, I guess we'll have to do that twice or something. Does slot value work on slot value? In particular, that the behavior for conditions and structures is not specified. Fuck. But I think if we use the mop slot value using class, we should be fine. Hopefully. Question mark. Whatever, fuck it. So we're gonna do loop for slots and no. Class slots class of struct and conc compute assets. I'll just refer to this now. Slot definition name slot. And then we replicate that for standard object. So we don't call it struct anymore. Okay. What else? Hash tables, right. Do we want to consider keys for this? Probably not. Use of table and conc. Covers that. Viewed assets of an asset itself should reverse further, so it has and conc call next method plus itself. Whoops. There we go. And we need to check whether the slot is bound actually. So can constructor slots be unbound? Is that possible? Make fart. No, I don't think it is. Is it? Def struct. Named predicate type. This should find it all. Unbound, choose nothing. An issue that might be relevant. Most symbols which name the structure also be bound as long the variable for the default keyboard construction function. It's not what I look for. Not sure it cares. Is there another section I'm missing here that defines this behavior? Maybe the slot type. No. Consequences are undefined if an attempt is later made to reach the slot value before values explicitly assigned. Okay. There we go. That's the answer. So what do we do? Guess just one slot.
What was the answer? You read it too fast.
The answer is it is undefined. What the value is. It is undefined behavior if you try to read the value of a slot that has no init form and has not been yet assigned. And slot bound piece. Right? No, because yeah, I'm not even loaded yet. But I think this is it. This is all we need for this system to work. Before that, let me see, can
I think SBCL errors if you do TTRY that.
no it doesn't. Or at least you can print it and it says no. So if I have, part A, no it doesn't error, it assigns no. I need to detect if this happens. If what happens. I mean, I could shove the slot access into an ignore errors thingy and then just not do that. Not add it to the traversal or whatever. That's a possibility. But I think if I just use slot bound P, I should be fine, I hope. Alright, what do I want to do? I want to have a number of assets. It's D, and that's hash table count, assets context. And now I should probably load trial at some point. That would be useful. Yep. I'm gonna talk about what I did today and yesterday in a bit, because we're almost done. Yep, that works. Loader. No, that doesn't work. Why not? What do you don't like? Then, yeah, okay, typo. And what else? Undefined. Oh, it's not called unload, it's called offload. That should be vor. What? Oh my god. Typos today. Okay, now we're fine. Good. Let me slam this into the ESD, and once the tree pops up, I can see where it is. Loader is layer set. Layer set. File loader depends on package and scene and asset, I believe. Though arguably this could be in the asset definition. Depends on how you see the dependency. I think the other way around. So we want to have asset. Good. That should cover for that. Let's check it. Yep, checks out. Good. Okay. Now, what we want to do is consider how to do this. Actually in the loader, we want to have, actually I want to, let me just add some debug info here. And this should actually be before, so that we can catch the error. Info trial loader offloading the info trial loader transitioning from fonts to length to upload. No, wait, to load. Ah. There we go. And then we probably want to return the new scene, just to be nice. Okay. Okay. There's a load of legacy code in trial now that we can throw out. If this stuff works as I want it to. So let me go here. Workbench, we're gonna populate the scene with hey, what was it? Time machine. Wanna have the thing back where we had a nice thingy. There we go, it's skybox stuff. Teapot grid. So we're gonna do this. We're gonna do this. Skybox. And enter skybox into the scene, and then when we transition, we are gonna have a teapot as well, because why not? That. And we're gonna have vertex colored, texture, located, rotated, selectable. Oh, whoa, 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 whoa. The no velocity, vertex rate, texture, rotation. Yeah, that works out. And then we're gonna have wait, we have a reload assets function is F5, which doesn't work, by the way. It fucks things up. So we should define handler controller. What was that? So in this we can have a new scene, make instance scene, lock visible name. Okay, and then we're gonna enter the stuff on the skybox so that's not offloaded. New And I think it's just loop, so unit skybox old new enter since teapot new position from the old to the new, and then set a scene main. Actually, now that I think about it, this isn't gonna work well. Fuck. Where's the main coming from? Is the main found? I don't think so. I got rid of that. Yes, it's not. And the scene doesn't have any... The context doesn't have any way of doing that, so we're gonna have to do this. And that's still not good enough because we would do this. Things are more complicated than I thought. As usual. The reason they're more complicated is because scene is not only a scene graph, but also an event loop. And there might be objects on there on the event loop that are not on in the scene graph. And you wanna have that working. Okay. Takes care of these special cases. Now the other problem is the assets in the pipeline. Because the pipeline is something I didn't think about as usual. Fuck. Might also want to actually transition between pipelines. Fuck. Fuck. Should the pipeline be part of the scene? That's a good question, actually. I'm tending towards a yes. Okay. So, back to the drawing board for a bit. Aside from the scene, which contains the objects you interact with and the objects you see, here's a pipeline. And the pipeline is basically pipeline is a section or a list of stages. And these stages perform rendering operations. Or more specifically, the stages are what actually execute GL rendering stuff. And they designate what is drawn and how it is drawn. They're fairly important. Now, the stages also control a fair amount of assets. I've explained this last time about how the system works, but essentially each stage has a container of shader programs and shaders that it has for each object, which it needs to use to draw the objects in the proper way. So there is a couple of assets in there as well that need to be managed like this. Now, what I'm thinking about is that currently how it works is that the pipeline and the scene are tied to a main object, which is basically just the window. Well, the main object has a context. Context is an OpenGL window. It has a scene. It has a pipeline. And it has a controller. It also implements a couple of things like display and renderable that allow you to draw things properly. Display is the minimal class that contains a context, and renderable is something that refreshes itself automatically, so it has a frame rate. And the main is basically that plus a scene and a pipeline and a controller. Now, what I'm thinking about is taking this out and stuffing it into the scene, because it seems fairly sensible to tie this into it, given that, you know, if the scene is supposed to contain literally everything, including all the assets, and contain all the information about how something is drawn, then it seems only logical that it would also contain a pipeline that tells it that, you know, does things. The problem I have with that is the fact that it would create a dependency from the scene to the stage, which means you would no longer be able to use a scene without a pipeline, which means as soon as you want to use the scenes, you're locked into using the pipeline system. Now, one of the main goals of Trial is to be sort of a toolkit of things you can use relatively independently. And that would most definitely violate that pretty badly. So I don't know. Maybe the solution is making a subclass for pipeline scene or something. Pipeline scene, which is a scene. Maybe also a pipeline at the same time? Does that make sense? Let me check. If we can merge these, it has a handle which does just a process. It's an event loop. An entity, load, finalize, register. Yeah, that would make sense, I think. So it would inherit from scene and pipeline. And then you can add things to it. Yeah, I think that makes sense. I think that makes sense. And then the main would use any kind of scene object, but probably a pipeline scene by default. Yeah. That seems like a good idea. And then the transition would automatically pick that up because it traverses the scene. And the associated objects that will work. I'm actually noticing a potential corner case now, where you know how we have this baking system, but it is also possible, especially if we consider the streaming, that an object might create and load assets on its own during the runtime of your thing. So while the scene stays consistent, an object might change assets. And then what? It's unloaded. That's no problem. It's gonna be discovered. It's reloaded. Also no problem because it's the same. Then no, I don't think that's an issue. Shouldn't be. It shouldn't be. Ah, boy. As I mentioned at the beginning, I've been coding all day and debugging stuff on all operating systems, and it's been really tiring, so I'm kinda tuckered out. But I think this should work. But I don't think I can make it work tonight. Not enough time left. Okay, so what do we need to do? We need to eliminate a lot of stuff. Yeah, I need to do a lot of cleanup before this is probably gonna work right. Pipeline, scene, pipeline. And that might work out. Probably won't, as I expected to. So, that's not it. Main. So, no, wait, so in main we have get rid of pipeline, frame pipeline. Why is that thing? Oh yeah, because, fuck. That's another thing I didn't consider. There's two different pipelines depending on whether you want to render to a texture or to the screen. Because if you want to render to the screen, you need to do a final step of bleeding. That should probably be part of the main though, or of the display or something. What does it do? Yeah, it has an author method. Yeah, that should probably not be part of this, and instead be a part of main. But I'm getting a headache considering all the changes and dependencies and all those things to make sure that this works as I intended. So... oh boy, okay, if I rearrange things that the pipeline is part of this, this should be fine now, I think. The frame pipeline needs to go away. Do I use it anywhere? Don't think so. Frame pipeline. Yeah, it's just a main. So we could get rid of this, get rid of that. Blind scene. Reload, finalize, scene. Event, issue process. Load, start scene. Add a pipeline. Probably have a scene argument here. There's something. Back pipeline. Paint. This is another thing that... Yeah, I don't think I can... I need to sleep on this and rethink it with a clear mind. Currently I can't cram all the details of how the individual parts of the system work into my head, so I can't make out a clear plan on how to go about this. So unfortunately, this won't end up in a demonstration of it working, but hopefully we'll get to that next week, or I'll get to that until then. Yeah.
Yeah, it's getting big.
What do you mean it's getting big? It's fucking huge already. There's so much shit in here. The problem is that, like, all this stuff around scenes and the main and the pipeline are fairly intertwined already, to a point that I really don't like it. So tearing these things apart and making it more clean in its relations is definitely something that's been overdue. Overdue. So yeah, but I need to stop thinking about that. I'll push this because it's independent. Implement first parts of an automated stage scene transitions touchdown. Another part to this would be adding loading screens that are automatic, so that you can easily plug in and show a loading screen while the transition happens. That's another thing to consider. But yeah, for another time, that'll need some fancy stuff. Anyway, yeah. Alright, I wanted to talk about what I did yesterday and today. So, last week, or was it just yesterday? No, last week I refactored the gamepad system in trial, and then today I completely ripped it out again. So what I did was well, okay, so in trial we use a system called CL Gamepad, which is a minimal implementation of gamepad and like controller stuff. The problem is that the only thing it supplies you with is sort of an index for which button and which axis is currently being changed, but it doesn't tell you what that button is, what its functionality is supposed to be, or anything at all. It's just an integer. and this integer might even not be for the same button or axis between different operating systems or between different controllers. So pretty much have no idea what it is unless you use trial and error to figure out what corresponds to what. Now that's not so great. Trial had a system where you could define sort of a gamepad mapping that mapped these indices to standardized labels for each axis and button. Turns out that's not good enough yet, because sometimes on some systems some of the axes are reversed. So they go into the opposite direction from usual for some reason. I don't know why this is, but it's a thing. So I changed the system to allow you to define a multiplier for each axis in order to be able to reverse its direction. And then I realized the system kind of blows because we do a lot of lookups and other kinds of things that make it way slower than necessary. So I rewrote it. And then I realized, okay, so my rewrite is still kind of garbage because I had a hash table that had the mappings in it, and then every time a button was pressed or an axis was moved, it would have to do a hash table lookup based on the device vendor and product IDs, and then use that table to make another lookup on which button it is. So what I've done instead is I faked the mapping system into the gamepad library itself. So if we go into some gamepad, there's now a system in place that defines enums for all buttons. So you have a standard set of buttons that are known: X, Y, Z, A, B, C, L1, L2, R1, R2, left stick, right stick, D-pad, select home, start, trigger, and so forth. And the same for axis. And you have a new struct, which is a gamepad device map, which is basically just a collection of arrays in which you can index with your current button or axis ID, and thus lookup of the label is extremely cheap. Each device has a pointer to such a device map, so you can look it up easily. And then you have functions to retrieve and set a device map for given vendor and product ID. So this is now baked into the system, and I've also added the same stuff to CL Gamepad, so you have the bindings that work with that quite nicely. So you can define your gamepad stuff in a neat way, similar to what I used to do in Trial. So we have now a collection of databases for each operating system that define these mappings between the buttons and axes. Yeah. I also changed the visualizer, which is sort of a small system that I guess I can show off. Visualizer, which allows you to sort of configure such a mapping pretty easily. So here we go. And now I need to have a controller. I don't have one handy. The Pro controller unfortunately doesn't work. Thanks, Nintendo. Appreciate that. So now we have the DualShock 4 attached, and then you can see when I'm pressing D-pad or L1, L2, and you see the axis and stuff. So this is already a mapping that is known, but if it's unknown, you can click on any of the axes or buttons and then select one of the predefined labels, choose whether it should be inverted or not, okay it. And then once you have an entire mapping done, you can say export, and then you get this code here that describes the mapping. You throw it into the file, save it, and then the controller is defined for all time to come. So now defining new mappings is relatively easy. GG easy. So now in trial, all that's left is this one file here, which just basically does the
Map all the things.
lookup and issues an event for each gamepad event that it comes in. And that's it. So now all of that stuff is in CL Gamepad for everyone to use rather than being constrained to trial. So yeah, if you have controllers that are not yet in the bindings here, these are just the controllers I have. I have a couple more Nintendo ones, but they don't work on systems. But if you have controllers that are not listed here yet, I would really appreciate it if you could map them out and send the code my way. If possible, map them out on all 3 operating systems. If not, that's fine too. Yeah. Some of them are really easy. If they're like Xbox 360 compatible, they're gonna have the same mappings. So you can just write out their device IDs and say inherit, and then it's gonna copy the mappings over automatically. But yeah, that's what I did. Yeah, right. That's it for the treehouse, I think. I'll let you know next time if I finish the loading thing on my own, or otherwise we're probably gonna continue with this. Yeah. It. Thanks for rehousing. Hooray!